Okay, so we are looking at the expansion of 2 minus x over 2 to the power of 7 in ascending powers of x, okay, for the first 4 terms. Okay, so using the formula, we'll get 2 to the power of 7 first. 7 choose 1. 2 to the power of 6. Negative x over 2. Power of 1. Okay, so for the expansion, you should be able to get this. Alright. Yesterday, as I walked around, okay, I think one of you asked me, okay, what happens to the plus minus, the alternating plus minus sign? Okay, notice that in my presentation, okay, usually when it is a minus sign, I'll just keep everything to be just plus operation. Okay, my minus sign is incorporated into my b value over here. Okay, I recognize my b as negative x over 2. Alright, so I place the negative sign within b. Maybe I'll use a different color. Okay, naturally when you actually apply your indices law, your operations will actually change. Okay, so therefore I usually don't actually put the plus minus as a in case it confuses you, okay? And then also it may not be a hard and fast rule that you always apply that way as well. Alright, so simplifying this expression, okay, what you will get is 128. Then minus away, okay, minus because this is minus to the power of 1, so therefore there will be a minus sign. 7 choose 1, you get 7. Okay, 2 to the power of 6, what do you get? Let me get my calculator. You will get 64, right? Okay, this will then be x over 2. Okay, then 7 choose 2. It will be 21. 2 to the power of 5, 32. Okay, really up to your personal preference to what extent you like to actually go about doing your simplification. So what I've done over here, in case some of you are a little bit lost still, okay, 7 choose 1 is 7, 2 to the power of 6, 64. Okay, negative sign I have already brought it out here. Okay, because it is power of 1. X over 2 maintains. Okay, 7 choose 2, 21, 2 to the power of 5, 32. X over 2 bracket square. Negative square maintains a plus, so there's no negative sign here. X over 2 bracket square means x squared, 2 squared. So 2 squared is 4. Okay, 7 choose 3, 35. 2 to the power of 4, 16. Negative to the power of 3 means that you have your negative sign over here. Okay, then after that over 8, because 2 to the power of 3 is 8, and then x cubed in the numerator. Okay, then you can proceed with simplifying. Continue to simplify, you get 1 to 8. 7 times 64 divide by 2, press that into your calculator, and you would get 224. Okay, followed by plus 168 x squared minus away 70 x cubed. Okay, I hope that you're able to get this answer. Any questions? Right? Next one, part 2 is the one that maybe you have a bit of hard time in thinking. Okay, so question asks, what value of x will you substitute into the expansion? Okay, into this expansion in order to estimate 1.995 to the power 7. And then you're asked to justify it as well. Okay, let's do things part by part. The first thing is to know what is the value of x that we want to use. Okay, we're trying to estimate 1.995. So 2 minus x over 2 to the power of 7. We want to draw reference, okay, to this in order to find out what is 1.995. Okay, so the only comparison that is logical will be to think about 2 minus x over 2 to be equals to 1.995. Okay, then after that, okay, solve this algebraically. Okay, and you find that x will be equals to 0.01. Okay, so we choose x equals to 0.01 in order to help us estimate the value of 1.995 to the power of 7. Okay, the question is, why is it only an estimate? Okay, in the entire question in your textbook, it says to make use of the expansion. Okay, that means your expansion in part I. Your expansion in part I is not complete because you only expanded up to the first 4 terms. You did not expand the remaining. Okay, so if you use x equals to 0.01 and you place it inside here for the first 4 terms, the value over here will only be an estimated value, okay, to what you have, instead of the exact value of 1.995 to the power 7. You understand what I'm saying? Okay, so why is it actually a good value then? Okay, so we address about how is it estimate, okay, then after that to justify whether is it a good value or not. Okay, so I'm just not yet writing my answers, I'll write it later on. So x equals to 0.01, where are we placing the x in? We're placing it here, here and here. Okay, notice that the value of x increasingly in powers over here. So if you were to think about 0.01, okay, versus 0.01 square versus 0.01 cube. If you just key that into your calculator, okay, let me just key that in as well. We find that this is 0.0001 and this is 0.000001. Okay? So what do we understand about this? Okay, what's the purpose of doing this? We notice that 0.01 cube, or rather x cube, is definitely smaller than 0.01. Okay, this number is smaller than this one. So what happens when it is smaller? Okay, when you continue to do your addition or subtraction, for the fact that this is going to be smaller, the impact to the entire number is not that big. Okay, so this one is 0.01 square, this one is 0.01. Okay, so overall, okay, the how should I put it? The variance, okay, the estimation itself will not veer too far away from the actual value, okay? Because 0.01 cube's impact is not as high as 0.01, okay? Because you're continuously adding or subtracting a certain number to it, okay? So let me write it down first, okay? Then you that sink in. So questions? Does anyone not understand this yet? Or still? Okay. The whole idea is that this one is a very, very small number. Okay, we are taking from 1 to 8 itself. Okay, to continue to add or subtract a certain number from 1 to 8. If you go and calculate in your calculator, 1.995 to the power of 7 is about 128. 5 point something. Okay, so we don't want to choose a value of x such that it will cause a very big fluctuation in the number from the 1 to 8 itself. Okay, so that's why 0.01, even at higher powers of x, okay, the fluctuation is not going to be so big. Okay, therefore 0.01 is actually a good estimate. Okay. Any questions? Okay, can I move on to the next one? Alright, so our next question we're going to be starting to look at the general term itself. Okay, so far whatever questions that we have been doing, we've been looking at the expansion. Okay, using the formula to do expansion to find the first 4 terms. Okay, the next part about the formula is to make use of it to find out, okay, the general term. That means every single term itself, okay, how would it actually look like? Okay, we can do that by using the formula. Yeah. Exercise 6.2 question 3 first. Okay, so I want to find the general term of the expansion x plus 2y to the power of 5. If you recall when I first introduced the formula to you, I mentioned that this part of the formula, okay, this part is your general term. Okay, and that term is actually the r plus 1 term. So this is your first term, this is your second term, this is your third, and then so on. Okay, and then after you have the last term. Okay, notice that when it is n choose 1, it is actually a second term, n choose 2, it is a third term. So n choose r will have to be plus 1 from r, so this term itself is the r plus 1 term. Okay, so it's not the r term, it is the r plus 1 term. Okay, what is the r term? It is just an algebraic letter to represent in general, okay, the sequence that we have over here. Okay, so to find the general term of x plus 2y to the power of 5, right? Okay, using my formula, I find this is the r plus 1 term. I use n to be 5. R is something that we do not know since we're looking for r plus 1 term. A is your x to the power of 5 minus r, and then 2y to the power of 5. Sorry, r. Okay, so this will be the so-called pattern, okay, to have for every single term in the expansion itself. That is what we call the general term. Okay. Okay, then after that, we need to simplify this, because the thing is that when we simplify, okay, in the process of simplification, what we want to achieve is to know, okay, exactly where is the coefficient and what are the variables. X and y are the variables, they are the unknowns over here. Okay, so we tend to have the coefficient first, then our variables. Coefficients, so example, okay, 20x squared, this is your coefficient, this is your variable. So we want to express it in this kind of form. 5 choose r is going to be a number, that is going to be a coefficient. Okay, let's keep the x to the power of 5 minus r here first. 2y bracket r means 2 to the power of r, y to the power of r. Okay, this bracket optional. Right? So we place all the numbers together. Okay, and then the variables at the end. okay, to achieve the general term. Any questions? Right? Let's try another one, part C. Okay, we also want to find the general term. So again, n is 13. Choose R. 3x squared will be the A. We have 13 minus R. Negative 1 over 2y. Okay, to the power of R. This will be our general term. Okay. Now at this juncture, this is the part where I want to explain why is it that I don't want you to start thinking when there's a minus sign in between, your symbols, they will go in a plus minus alternating manner. Okay? If you are so fixated on that, that means that your term B itself, okay, what you use as B will always be something positive. Okay? And then your expansion, well, the expansion is going to be correct. But then when it comes to this part, if you're fixed on thinking that this is going to be B, then you lose out on the negative sign. Okay, this negative sign is very important over here because it is to the power of R. We do not know is it going to simplify to be a negative sign or actually a positive sign. Okay, so in our expansion, right, it is always plus. Okay, then after that my B itself, I need to recognize in its totality with the negative sign involved. Okay, right. Now let's work together to actually do our simplification, okay? So our simplification, we want the coefficient and the variable section. 13 choose R will be something that's going to be a number if I know what is the value of R. This is the part that could be a bit tricky. You need to remember 3 to the power of 13 minus R. And then x squared to the power of 13 minus R. Okay, so we break down this part first to get this. Okay. Second portion, this part. Okay. This is the one that could be challenging. Okay. Need you to recognize that this is negative 1 over 2y, which is actually also the same as negative half times 1 over y to the power of R. Okay, so I can break it out as negative half to the power of R times 1 over y to the power of R. Okay? Okay. We recognize that this is a number that will be part of our coefficient already. The rest that will be computable numbers, so long as I know what is R, will be this part and this part. Okay, so the purple parts will give me this. Okay, so this is your coefficient section. Okay, then the remaining will be your x squared to the power of 13 minus R, which we can simplify to 26 minus 2R. Powers will have to multiply in this case. Followed by 1 over y to the power of R. We keep things into your negative index form. Okay, so y to the power of negative 1 will actually be 1 over y. So we write it as y to the power of negative R. Okay. Right. So usually we remove our variables from any idea of fraction. Okay, we write it as negative index. Right. Okay. Something that I want to also point out a must, okay, a trap that usually people would tend to fall into. This negative sign is inside the brackets, yeah. Okay, this bracket is extremely important. Okay, in fact, all the brackets that are written down, they are all important. Okay, so don't remove them, lah. Okay. Right. So this is yeah. The 5 minus r, y, this one, how did it become here? How did this come here? Okay, it is because 1 over y is y to the power negative 1. Right? So 1 over y to the power of r equals to y to the power negative r. Okay? And anything else to clarify? Yeah, so this is to build up to the next thing. Okay, we will look at try 9 now. Okay, so let's look at try 9. Okay, there's a reason why, okay, in the simplification process, I want the very clear distinction between coefficient and variable. Okay, because in questions like try 9, okay, a very typical question, they will ask to find the coefficient or find the eighth term. Okay, something like that. So let's figure out how to solve this question. Okay, in order for us to find the eighth term and the coefficient of any term, okay, we definitely need to use the general term formula. Please do not go and expand everything all the way until the eighth term or all the way till you find out what is the one that has x to the power of 10. That will be a waste of time. Okay, that's why we learn how to use the general term. Okay, so using the general term for the expansion of 1 plus x squared to the power of 14, our r plus 1 term would actually be your 14 choose r, 1 to the power of 14 minus r times x squared to the power of r. Okay? Right? We can simplify this. 1 to the power of 14 minus r, what would that be? That would just be 1, right? Because 1 times anything, okay, will actually just be 1. So we get 14 choose r, x to the power of 2r. Okay? So we can see that this is the coefficient, this is the variable. Okay? Question wants us to find the eighth term. That means that we're looking for T8. Okay? So eighth term is referring to T8. That would mean that r plus 1 needs to be equals to 8. Okay? So I can find out what is the value of r. That would be 7. Okay? I erase this part already, yeah? Okay? So with r equals to 7, that will then help me to find out what is the eighth term going to be. So when r equals to 7, T8 is going to be 14 choose 7, x to the power of 2 times 7, 14 choose 7, you can press your calculator to find that out. That would be equals to 3432. So 3432x to the power of 14. Okay. So that's the 8th term. Okay, so without having to do the full expansion, I can find what is the 8th term. I can find the things that are right in the middle. Okay. So that saves us a lot of time. Okay. At this juncture, anything to clarify? Yeah. Moving on to part 2. We want to find coefficient of x to the power of 10. Okay. So we want the coefficient, which is here, okay, and x to the power of 10. Alright? So I need to know what is the value of r in order to make use of my general term to identify the coefficient. Okay? Since I know I'm looking for x to the power of 10, that means 2r must be equal to 10. Okay, don't need to repeat these steps already, since we've already done part I. Okay, so that means r is equals to 5. Okay, and therefore the coefficient would be 14 choose 5, and that is 2002. I rephrase the question. Okay, the question essentially wants you to find the middle term of 2 minus x cubed to the power of 6. Okay, so where is this middle term? Okay, does it mean that I have to now go and expand everything? No. Okay, there's a logical way that we can find it. Okay, there's a pattern that we can observe. Right? So now let's track back a little bit. Okay, recall that we're always trying to expand a plus b to the power of n. When n is equals to 1, we see that my expansion will just be a plus b. Okay, when my power is equals to 2, I will know that it is going to give me a squared plus 2ab plus b squared. Okay, at this juncture, I want you to observe that when n is equals to 1, I get 2 terms. When n equals to 2, I get 3 terms. If n is equals to 5, how many terms do you think there will be? There's 6 terms. So there is always a plus 1 number of terms to the power. Okay? So number of terms will always be n plus 1. Alright? So with that realization of the pattern over here, that means that if I have 6 power 6 over here, I'm expecting it to have 7 terms. Okay, so if 7 terms, what is in the middle? Which term is the middle? 4th term, right? Okay, so therefore, we are just looking for 4th term. Right? So, would I give you this question to try? Go and find out what is the r plus 1. Simplify that first. Then after that, r plus 1 equals to 4. Use r equals to 3 to find out what is the middle term. Okay? I give you about 5 minutes to do that. Alright? negative 160x to the power of 9. Okay, so this is again where I want to emphasize the importance of this negative sign when the expansion is negative or minus sign over here. If you lose that minus sign, okay, then you will not get the correct term because it's supposed to be negative 160x to the power of 9. Okay, let's move on to look at part B. Independent of x. Okay, what does independent term means? Any ideas? What does independent mean? Away from probability already, yeah? Okay, so not related to probability. Okay, so independent of x will mean that there's no x at all. Okay, but no doesn't mean zero. Okay, sometimes we need to distinguish between the idea of no and zero. Okay, what it means is that in my general term itself, this is not present. That means that it is x to the power of 0. Okay, it cannot be a value of 0 because if the value is 0, then the entire term must be 0 already because it's multiplication, right? Okay, so that means your power over here needs to be a 0. Okay, so looking at this question, let's find the general term first. Okay, general term will be expressed in this manner, right? If you do not simplify this, okay, what's gonna happen? You find that x is found over here, x is also found over here. If you don't simplify, then you do not know, okay, how to figure out the zero placing is going to be. It doesn't mean that r is equals to 0, yeah? Okay, so you need to actually go about simplifying to get into the coefficient and variable form, right? So to work that out, this means that it is x to the power of 18 minus 2r. This will be 2 to the power of r, x to the power of negative r. Okay, then continue to simplify numbers together. Okay, oops, sorry, I forgot to close this. And then we get x to the power of 18 minus 2r plus negative r. So simplifies to 18 minus 3r. Simplified to that already. I have a single portion, single base of x. I want independent x. Independent of x, so 18 minus 3r is the part that needs to be 0. Then I can figure out what is the value of r. Okay. So if r equals to 6 already, I will find the term independent of x will actually be the 7th term. Naturally, this should be 0 already, so I'm skipping those steps. So that would be 5376. independent terms. So let's extend that idea. Since we're talking about independent terms, let's take a look at question 8 in exercise 6.2. Okay, I think that's on textbook page 151. So we want to explain why is it that the expansion of this part here does not have an independent, does not have a term that is independent of x. Okay, so we can figure that out by relying on the general term. So the general term would actually be 15 choose r, x to the power of 15 minus r, negative 1 over 2x power 8, then to the power of r. Okay, can I give you about 3 minutes? Okay, 2 minutes lah, let's push it a little. Okay, 2 minutes, go and simplify this for me into the coefficient variable form. Okay, simplify this for me, please. Okay, I think you don't need all the indices, practices, that's okay. still don't understand this idea of term independent of x, maybe let me repeat myself, okay? So term independent of x is when the term does not have x inside it, okay? We know that in our general term formula, okay, what's the purpose of the general term formula? Is to tell us that in this expansion itself, okay, if you stop dancing, right? So in this expansion itself, okay, every single section will go by a certain formula, a certain pattern, and that pattern is described based on this general term. Okay, so every single one follows this pattern over here. Okay, that's the purpose of a general term. Then in the general term itself, right? Okay, maybe let me use this one. Okay, in the general term itself, there will always be the part where there's a coefficient, the number, and there's also a part whereby there are x inside it, x or y and so on. Okay, so that is what we call the variable. If I want something that doesn't have x inside it, that's what we call independent of x. That means x doesn't appear. Okay, and we know that x doesn't appear when x is to the power of 0, because x to the power of 0 is equals to 1. I cannot have x to the power of something and still because it will still exist there, right? So the only possibility of independent of x is when x is to the power of 0. Okay, let me simplify this first, yeah? Okay, so that I can have something better to work with. This is question 8. Term, I can clearly see now I have one section only that has x in it. Okay, I cannot have my x all over the place. If x is all over the place, it's going to be very difficult, okay, to actually come together to know, okay, what is the power going to be. So I need to have all my x over here combined together into one part. Okay, this numerical part, the coefficient part, cannot be combined together. Okay, otherwise it will be just even more messy. Okay, so we just leave it in this manner. Okay, so term independent of x is when this part here doesn't exist in the whole term. Okay, independent, that's what independent means. Okay, away from x. Okay, that's the idea of independent one. Okay, away from something. Okay, just like you want to have your independence away from your parents, right? Okay, away. So away from x. Okay, so in order to be away from x, that can only happen when the power is equals to 0. If the power is, let's say, 2, the x must be there, what? Okay, it must be x squared. I cannot purposely don't put it out there. Don't put it there. Okay, so the power itself must be 0. Okay, power cannot be 1 as well, because power of 1 will mean that it's x to the power 1. X is still remaining there. The only way to make it disappear is that the power is 0. Okay, so away from your parents don't give you any power anymore, so power is 0. Okay, good analogy, right? So that's how you can remember. Okay, so in this case, okay, we want to answer the question. Haven't finished answering the question, We want to explain why it doesn't have a term that's independent of x. Okay, that means that, let's try. If I can solve this equation, okay, that means that there is a term independent of x. But if I try to solve this, I will find that my value of r is going to be 15 over 9, or if I put it into a mixed number, that would be equals to 1 and 6 over 9, or 1 and 2 over 3. Okay, can my r actually be a fraction? Cannot, because if r is a fraction, we're looking at a 2 and 2 over 3 term. It doesn't make sense, right? Our term is being counted in this whole number form. Okay, we cannot count for a fractional term itself. Okay, so because my r now is actually a fractional number, okay, therefore it is not possible for us to have a term independent of x in this particular question. So to explain that, we say that since r is not an integer, the expansion of x minus 1 over 2x of 8 of 15 does not have a term that is independent of x. Are we clearer now regarding your independent of x idea? Okay. Still not clear? Please do check in with me. Okay. Don't let it bother you for too long. Independent of x, we must get this true. Okay, because this word independent of x is very common to see in binomial expansion. Okay. So our questions are getting harder now. Okay. We want to look at the expansion of two things together. Okay. We have this part over here and this part over here. Okay. Seems quite like a torture actually, and then we have to see term independent of x. Okay, so how do we go about answering this question? Okay, we want the term independent of x for the whole expansion, not part by part. Okay, so let's do things part by part though. We can do this part first and then this part first. Okay, so expand this 2 plus 1 over 2x squared. How do we expand this? Do we use the formula? Yes. Who will use the formula to expand this? Okay. Who wouldn't use the formula to expand this? Okay. Kai, how will you expand it then? Sec 2 the a square plus 2ab plus b square, is it? Okay. Yes. This one power 2. Very simple expansion. Don't be so fixated on the binomial expansion. Okay, this one can give you a bit of headache. Just do the a square plus 2ab plus b square lah, Okay, so that is 2 square plus 2 times 2 times 1 over 2x plus 1 over 2x squared. Okay, don't make your life so difficult. Simplify to 4 plus 2 over x plus 1 over 4x squared. Okay, you sure you want to go now? Then you'll miss a lot. Okay, so now I expand already, so 1. Okay, am I going to expand this 1? Okay, we hold our horses first. Okay, from there, right, we need to know how does this actually work out? How will the expansion work? Okay, if I expand this, I know the things already, and if I expand this and I know the things already, okay, how will I eventually get the full expansion is by doing our rainbow method, right? Correct or not? But that is going to be a torture, right? If I want to do the rainbow method, okay, there is a logical way of doing things, Okay. we look at the things over here. Okay, let's find a smart way. We have 4. We want term independent of x. That means in this side of the expansion, I'm just going to look out for the one that has only a number. I don't want the one that has x inside it. Because by my rainbow method, my 4 itself just need to multiply by another number, then it will give me the term independent of x already. You understand what I'm saying? Okay. But then, of course, 4 is not the only one that is going to go through the rainbow method. My 2 over x also will go through the rainbow method. My 1 over 4x squared also will go through the rainbow method. So what does this tell me? I'm going to look for the one that is independent of x. Okay, in the other expansion, 2 over x. Okay, I want my eventual thing to be x to the power of 0. How do I so-called neutralize my this divided by x itself? I will look for a one that has just x itself, right? Okay, because this thing times this thing, then it will give me x to power 0, no more already. Because this is x to power of negative 1. How do I write this? This is 2x power negative 1. Okay, x power negative 1 times x power 1, negative 1 plus 1 give me 0. Okay, then my 1 over 4x squared is actually 1 over 4 x power negative 2. What should I multiply with in order to get my x to power 0? What should the power be over here? I have x power negative 2. I want to multiply by a term that has 2 in it, right? Okay, then I will get x power 0. Okay, so we don't torture ourselves by expanding this thing. We go and know how does the rainbow method works. Okay, then we go and look for all these terms. Okay, so now this is the next part that we have to do. Okay, by the way, I forgot to mention actually, independent of x, there's another word for it called constant term. Okay. Constant term means just a constant number, don't have x in it. Okay, they mean the same thing. Okay, so we need to find the constant term, x term, maybe go back to the correct term with x. And term with x squared. Okay, so that's what we want to look for. So in this expansion, don't go and expand the whole thing, use the general term idea. We get this. Simplify it. Now in. Okay. So got the general term ready in a very clean manner. We have the coefficient and then the variable. So let's look for the constant term first. Constant term is when x is to the power of 0. This is x power 1, x power 2. So that means that when this r is 0, it's a coincidence that r is 0. Okay, because now it's r only. Okay, so that means that I'm looking for the first term. And that would be 1. 7, sorry. No, 1. is equals to 1, we are looking at T2. Just to be clear, this is x plus 0. Okay, and then when r equals to 2, looking for the third term, that is 84x squared. Okay, so to answer the question now, going back to our rainbow method, our objective was to take 4 to multiply with the independent term, or the term independent of x actually, okay, which is 1. So we want 4 times 1 plus 2 over x is intended to multiply with this one. So 2 over x times negative 14x. And lastly, 84x squared was meant to multiply with 1 over 4x squared. Okay? Then you will get the answer negative 3. Okay? Because down here it cancels out already. Any questions here? Our brain is at the saturation level already. I can see from your eyes that you are at its maximum. Okay, so I will not go on. Alright? Let me tell you what is expected for tomorrow. Any questions still? Someone else still a bit lost here. Yes? Wait, okay, we use don't answer this one. That part lah. Okay, then actually right. Your question is? Sorry? Can you just expand and don't use general term? You can, okay? It's just a coincidence that's the first three. It may not always be the case, okay? So, actually it's asking, okay, can just expand the whole thing or not? You can, nobody's stopping you. You want to expand literally all this until it's full 8 terms, you can do it, okay? But then, I want to share that it may not be efficient, yeah. Okay, and it's a coincidence that it is actually the first 3 terms, okay, that we just need for the expansion itself. It may not always be the first 3 terms. Alright? Then Harry's question was this one. Okay. Anybody else who have a question? Yes. Sorry? The part when you don't understand how the matching works. Okay. Where should I start first? Okay, maybe I start with the matching one first. Okay. We know our rainbow method, right? Okay, our rainbow method is that this part here is the expansion of this. We have 3 things here. The 3 things are these 3. Okay, by my rainbow method, first thing here, I will rainbow everything. Right? Second one, I will rainbow everything also. Third one, I will also rainbow everything. Alright? This one, okay, which is 4, I want to so-called rainbow and multiply such that eventually when they come together, the product, the ending will be something that has x power 0. This one already x power 0 because x is not there. Okay, I want to multiply with a term that also doesn't have x. Okay, I want to multiply with a term that also doesn't have x in order to have no x at all. Right? So that's why we go and look for a term that's independent of x, that the power must be 0. Okay? Likewise for this is 2 over x. I want to multiply with something, okay, such that end up I don't have the x at all. So I'm trying to cancel away this x. And the cancellation of x is only possible when the other thing has an x in the numerator. That means x power 1. So same thing applies over here. We're looking at the idea of cancellation. That's why over here, you see when we multiply, it cancels out like that. Okay? Then Harry, your question is to understand how the numbers move in. Do you understand already? Oh, okay, can. Any other questions? Okay, you all look very dead already. Alright.